Here are your example problems for 7-6. 7-6 is about slope and similar triangles. So we're going to apply what we've learned about similar triangles to the concept of slope. Let's look at our first point here. In the figure shown, triangle ABC, this triangle here, and BDE are similar. They're slope triangles. Triangle ABC and triangle BDE are slope triangles. Slope triangles are always similar. So we could take a look at this and say that BAC, that would be BAC, this angle here is congruent to DBE, that would be this angle here. We can see that they're congruent. You can also immediately recognize that these two are congruent to each other. So since we have two congruent angles, by the way, B and D are also congruent angles, but since we already see that we have two congruent angles, and we're given those two things right there in the diagram, we can show that we have angle-angle similarity, just like we did in the last lesson. So you can use the properties of similar triangles to show the ratios of the rise to the run for each right triangle are equal. So we've shown that the two triangles are similar. Let's take a look at problem number 1. Write a proportion comparing the rise to the run for each of the similar slope triangles shown above. First of all, we don't have those there, so I'm going to quick draw these in here. Okay, so the first thing they want to do is show that AC, so this right here, and BE are corresponding sides. So the ratio of AC to BE would be blue, and then the ratio of BC to DE, those also are corresponding sides, so those two ratios should equal each other. So then what we can do is we could use the cross products. So we could say that AC times DE, that's right here, and then BE times BC is right here. Then by using the division property of equality, we could divide both of these. So we have AC times DE. We're going to divide it by BC times DE. You'll see why we chose that in a minute. Since we divided this side by it, that's why we're using the property of equality. We divide one side by it, we have to divide the other side by the same thing, BC times DE. Well, by doing that, you can see that you can then cross-simplify here. BC over BC is 1, so we can get rid of it. DE over DE is 1, we can get rid of that. And what you're left on the left side is AC over BC equals BE over DE. And that's after we simplify it. So now we can look at the diagram and see that AC is 6. And we can look at the diagram and see that BC is 3. And BE is 4, and DE is 2. So we can see that indeed we have 6 over 3 does equal 4 over 2. In both cases we have simplified down to 2. Now some of you are going to look at that and say that this seems like an awful lot of work to do, when really what we showed was 6 over 3 equals 4 over 2. And now let's go back up to the original one here so we can see the diagram. And you can see that what we were looking at was 6 over 3 and 4 over 2. And 6 was AC, this was BC. And hopefully what you're doing is you're saying, well, I can just look at AC and count it up and say 2, 4, 6 and say that that side is 6. I can look at BC and look at it and say that side is 3. I can look at BE and say that side is 4, and I can look at, that was DE there, by the way, and see that that's 2. And I agree with you, this is the better way to do it. What they're trying to show you here was that you can prove that this works without actually measuring the, without actually using a scale here to count them. It's the concept that they want you to understand here. Please press pause and do letter A. Okay, let's look at this concept here, similar triangles and slope. The ratio of the rise to the run of two slope triangles, that's what these are called, as slope triangles because they're both on the same line, formed by a line is equal to the slope of the line. So for the larger triangle, we would say that the rise is 6 and the run is -3, or we would have a slope of -2. For the smaller triangle, we can see that the rise is 2 and the run is -1. We're still talking about -2. So the slope in both cases is -2. And you would, of course, say that, of course, the slope is the same. Both triangles are on the same line. The ratios of the rise to the run of two similar slope triangles in example 1 are the same as the slope of the line. Since the ratios are equal, the slope m of a line is the same between any two distinct points on a non-vertical line in the coordinate plane. So that's what they're trying to do, is to firm up this idea of any place on a line, as long as it's non-vertical, of course, like it says here. Any place on a line, the slope will be the same. And that's what they're trying to reinforce here. Let's take a look at problem number 2. The pitch of a roof refers to the slope of the roof line. Choose 2 points on the roof and find the pitch of the roof shown. Then verify that the pitch is the same by choosing a different set of points. Now you can do this one of two ways. You can look at this and calculate coordinates and do it the way that they're doing it, by doing this right here where you do y2 minus y1 over x2 minus x1. But personally, since this is right here, you can go ahead and look at this. If that's the way you want to do it, go right ahead. That will certainly work. What I'm going to do is I'm going to take a look at it, and we're just going to do some counting. So if we look at the first one here, they're saying 8 minus 6, so obviously they're talking about this triangle here. So when it comes to the rise, I'm just going to write the rise in on this side. Right here is my rise, and you can see that that is a rise of 2. And then if I come across this way, I can count that up and see that that's 4. So I have a rise of 2 over 4, just like they found, which of course is 1/2. Now if I look at the other one, I can look at this part right here and see that that's a rise of 1. And in this case, we have a run of positive 2. So in this case, we have 1/2. Now the way they did it, they ended up with negative numbers, but that's all right. Notice that they ended up with negative numbers in both cases, and a -1 divided by -2 is still 1/2. So in both cases, we've proved that the slope is 1/2 in each case. Please press pause and do letter B.